So basically we're going to go through two of the most important or pretty basic text embedding techniques. So there are a lot of text embedding techniques. What is the meaning of text embedding? We're going to understand first. Basically, let's say we have a text. The cat sat on the mat. The dog sat on the mat. We have these kind of texts. Okay, these are the corpus, or basically the data set you can talk about. So using this data set you have to find basically the vectors of it. So why do I need vectors of it? The reason why we need a vector of it is to find the similarity between them. Okay, whatever I'm talking about does not make sense if you are hearing about it for the first time, but the idea is basically this: we have these sentences or the data set, and we have to convert the words or the things into embeddings. The reason is, let's say the dog sat on the mat, the cat sat on the mat, and the dog sat on the mat. So there is a high possibility that animals actually sat on the mat, right? So sat, or you can think of something like it was raining. Okay, it was raining and I picked up the umbrella. Okay, these two are pretty close sentences. So computer does not understand strings. We have to compute the similarity between them using a mathematical term. So we use vectors for it. So if we use something like a vector for these two sentences, then we can pretty much get like in a structure of a vector space where these two vectors, let's say raining and umbrella, will going to be pretty close to each other, because they have similar kind of, like, they will going to produce similar kind of embeddings. But this embedding thing actually depends a lot on the structure we are building it, or the text embeddings we are using for it. So how much semantically it will be correct, it entirely depends on which text embedding technique we are using. So using that particular thing, we can find similarity between them pretty easily. So right now in this video, we're going to understand about two of the main foundational embedding techniques, which will going to be pretty useful in not directly, but in other advanced embedding techniques. So at first, we're going to talk about something called one-shot embedding. One shot or one hot embedding, I think I'm forgetting about it. It's probably one hot encoding. So one hot encoding basically means that, I could be wrong, just check it out if it is one hot or one shot. So one hot encoding basically means that we will going to convert the value of something in order of the corpus. So basically means, like, we use something called binary vectorization for it. Let's say I have the cat. Okay, this particular value, okay, this particular corpus I had. So if I try to find the one hot encoding of this, so basically this will going to be something like, we're going to find out all the characteristics, and what we are going to do, we basically convert it. So the cat sat on the mat, and then there is dog. So because all the unique words are there, so what I'm going to do, I'm going to find the one hot encoding of it. The one hot encoding will be something like this. So at first, the one hot encoding for D. Okay, let me paste it right here, and I'm just going to reverse it. It's not the correct option, I guess. I think this one. Okay, so this is the one hot encoding for the will going to be something like this. Okay, so as the is coming at the first, so the will be basically the one hot encoding for this. Similarly, for cat we're going to use this particular thing. So basically the index or kind of that particular thing of it, where where basically the thing lies. Okay, so if I give you a more textual definition of it, I have to go here. Okay, so basically if I go a more textual definition of it, one hot encoding if I have any textual definition, yes, you can see right here, this is more of a worked example, but the idea is this, that if you have apple, mango, apple, orange. Okay, this is not entirely the one hot encoding or the thing I'm finding right now. One hot encoding NLP, if I search it specifically for it, it's shitty AI though. Yeah, build ideas with logic and code. So build will be at first, so I am putting it right here. So like basically numerical form of unique word, it's a binary vector where like all of the things will be in binary, as you can see right here. Similarly, if you find the binary for sat, you can pretty much guessed it, it will be something like this. So this is a kind of, you can say this is the more textual definition of like one hot encoding. Then there is another encoding, but it is not semantically correct. You can understand pretty easily. There is no semantic, we are not like extracting any features from it using which we can identify or vectorize it. So it is just a basic vectorization, as you can think of. Then there is BOW, or the which is called the bag of words. Okay, what happened? Bag of words. BOW, or the bag of words. This basically does the same thing, but removes all the punctuation. So if I have something like this right here for bag of words, what I can do, I can find like I'm going to remove the whole thing and suppress the punctuation. So the cat, sat, the, mat, dog. Let's say this is a punctuation based thing, but this has one particular characteristics which is basically finding the frequency of it also. Okay, right here this is more of a like binary vector, so 0 and 1 will be there, but in this particular case we also find the frequency. So let's say the cat will basically be something like 0 0 0 0, as like it is at first, and we have 5 features right here. So yeah, that is sat is one time, so sat will be at second. Cool. Remember, for the case of the, so the actually exists on the first sentence for 2 time. Right now I'm finding the vector for the first document. So this is the vector of the first document. Okay, So if I try to find the frequency of the in the first document, this will basically be something like 0 0 2 0 0. Mat is one time, so again 0 0 0 1 0. Dog does not exist into this, so everything will be 0 into this particular vector because of this particular document. So this is the bag of words. We have a lot of different type of text embedding models are there, and I'm going to discuss about them in a little short manner. So this is the word embedding vector models. You can pretty much read about it from any other YouTube video. This is as good as that, because like if I'm trying to teach everything right here, it will be pretty waste of my time, because already these kind of things exist. So What2Vec is the most popular one. You can use neural networks for training this particular thing. How to use it, how it actually is been done, is uses two concepts. First concept of sliding window, and the second concept of artificial neural network for predicting the next particular thing, or the predicting the middle value. So, and skipgram does the opposite of it. So if you already know these kind of things, you find it pretty easy to understand, but if you don't know, that's fine. TF-IDF I'm going to explain in a new video in a more detail, or probably I'm going to create a project on it which I'm going to share. BERT is the particular model we basically use most of the times. GPT is also creating different type of embeddings right now, so it has some things idea of it. So this is mostly about word vectorization. You can pretty much find a lot of topics in it, so this is the mostly trending topic. You can find more resources from other videos. So yeah, pretty much.